All right. So I'll go ahead and get started then. If it's all good to go.
Yeah, you can start now.
Awesome. All right. So welcome everyone. My name is Mark Gitkin, and I'm the current president of the design team Gatorloop, the University of Florida's entry into Hyperloop competitions. Today, I'll be taking you guys through a little project we've been working on that we like to call TinyPod. But before we delve any further, I do want to share a bit more about our team. So our team has been around for about 6 years now, and throughout this time, we have given ourselves a mission to follow from year to year as students come and go. Our mission is to foster the growth of our students to create the most advanced Hyperloop systems in Florida. In other words, while we build our Hyperloop tech, we want to make sure our younger and older members alike are improving as students, as engineers, and as people in an ever changing world. What we can do to help our members learn always comes first, and this is the mentality that we had as we entered into a full COVID semester last fall. So, we had a small problem at the start of that semester that I'm sure many teams experienced throughout COVID. We were fully online with all meetings and work required to be virtual. Most of our facilities were closed or on shorter schedules, and our initial budget was a third of what we had to start the previous year. On top of that, the majority of our members that semester were new to the university, with many of our experienced members having had graduated. We were in a difficult situation, and we were in no position to start exploring some new improvements to our design as we had previously hoped. This wasn't helped by the fact that our capability for testing was limited and it would need to be built up alongside anything new we might have developed. We needed a way to get going with creating the next Gatorloop vehicle while making sure to keep everyone on board and staying on pace. Now, how would we do that? So, our solution came in the form of TinyPod. TinyPod is a small scale Hyperloop vehicle prototype that acts as a test bed for different designs while also acting as an educational project for students. When developing this concept, we prioritize simplicity and cost in order to give our members a chance to not only design, but also manufacture many of the components for experience. And over here, you can see this is the current render, the current version of our TinyPod. To take you through this process in detail, I'll start from the very beginning, during our concept generation phase. We wanted to make sure we can bring our new members up to speed, especially while giving them something to try their hand at. Thanks to the great work from one of our senior members, David Adamczyk, we developed the new engineering member onboarding process, or NEMO for short. Throughout this program, we taught our students through workshops and short lectures on different engineering topics and techniques. After taking them through these steps, we then gave them a small design project for the respective subsystem or subsystems they were interested in working on. As they started on the project, each student had an older member or team lead to assist them as they progressed. By the project deadline, each student had developed their very own design by using their newly learned skills, and these designs were then compared and analyzed together. The final version of these subsystem projects were then implemented into the TinyPod design, meaning that many of the students would get a chance to see their work realized in a physical product once manufacturing could get underway. In this way, we pieced together TinyPod, with our senior members stepping in to make changes as needed for assembly, ease of manufacturing, or small slip-ups in design. As we were in the midst of designing TinyPod, one of our focuses was designing the system for in-house manufacturing. Due to our decreased budget, using the university resources was of utmost importance. Due to our focus on this, all but one of our custom parts is likely to be outsourced, with that component being the brake housing you guys can see here on the right. This requirement also brought a bonus with it in the form of a new opportunity to teach our students different manufacturing methods. As we move through manufacturing this semester, our students are actually getting a chance to work on mills, lathes, welding stations, and more, providing them with experience that they would not have gotten until much later in their college career. Other than manufacturing, design for assembly and disassembly was also a vital aspect of our design. All of our components are easy to assemble, with fasteners being our primary method of securing parts. We particularly use fasteners more in order to also limit the amount of permanent parts in our pod, so that it can be modified later on as our tests change with new developments. One example of all these implementations is the aluminum structure, shown here in the bottom left corner. This backbone of our vehicle is made up of 7 primary parts: 4 lateral suspension plates, 2 braking plates, and 1 main plate. The main plate only needs drilling operations for manufacturing, while the suspension and brake plates are to be cut using a water jet. These side plates can always be replaced as necessary, and this process is made simpler due to the plates being secured with fasteners and brackets. Besides the structure, the other subsystems shown here are the vertical suspension in the center and then the braking system on the right. Note that all of these subsystems were developed under NEMO, with special focus on the braking system, which was actually developed with 3 projects working in conjunction. As mentioned before, one of the goals of TinyPod was to develop it for future testing of our next vehicles and their subsystems. In order to meet this requirement, we focused on making sure our system was modular in form. This meant that our parts needed to be easily switched out, as well as that they needed to be accommodating for different size components. As mentioned in the previous slide, we fulfilled the assembly and modularity tasks by using fasteners in much of our design. On top of that, each of our subsystems has plenty of capability to be changed to a different version of itself. A prime example of this is the braking system, which is currently designed as pneumatic-based brakes, with some of the brake lines shown here in the center. While we currently are using pneumatics, we have the space and capability to maybe change to hydraulics, or maybe even to eddy current brakes, which we're currently working on developing. Yet another example of this modular testing capability is the lateral suspension system, shown in the bottom left. This subsystem also can be changed to fit different models, especially if we are looking to compare the performance of various geometry. This type of modularity is what we aim for and hope to achieve with all the other subsystems as well. Also, as was the case for the previous slide, all of these projects were done through NEMO, including the propulsion system seen on the right side of the slide. Another vital aspect of our TinyPod is its low cost, which can be attributed to the simple design of many of its custom components. At the current state of the vehicle, the total cost of TinyPod currently sits under $5,000 US. One system that helps meet that goal is the battery, which is made up of a pack of single-cell batteries connected together, particularly using the batteries you can see there on the right. Assembling this battery pack in this manner allows us to change our power output accordingly with different tests, while also keeping costs low for our battery. Other than making our own simple subsystems, we also made sure to find the cost-effective options when working with off-the-shelf components, like with our electronic boards. Using boards and sensors from companies like Adafruit help bring our costs down while still maintaining our necessary requirements for our system. Now, after all this, we still do have a lot of work that's ahead of us in order to get a finished product. We do have renewed access to manufacturing locations on campus now, and so we're planning on continuing fabricating our vehicle the rest of this semester and going into next semester. We're also currently working on finalizing our communication scheme to and from the vehicle during its runs, but other than that, we're hoping to soon be able to begin testing of different parts of our prototype in order to work out any remaining issues with our design and to start using our TinyPod. Questions?
Thank you, Mark, and the whole Gatorloop team for the presentation. It was really informational. So in the audience, if you guys have any questions, you could either enter it in the chat or unmute yourself and ask Mark directly. He'll have his presentation on. Yeah, so feel free to ask questions.
Not sure if anyone's typing or not, but
I was actually wondering how you heard about the Canadian Hyperloop conference, given that you're like from America, right?
yeah, I'm on the Hyper Co-op Slack channel and heard about CHC from there. So I've been, Krista has been posting there periodically, so I've been keeping in touch through that.
Awesome, thanks.
So one thing for sure is that we're currently still working through some of our sensors as we have made some changes to some of the subsystems. So like, for example, the lateral suspension that we showed there, there's currently an updated version of it that's being worked on right now. And so the sensors are still being modified as we work with those other systems. So I don't know if we're still using that sensor in our current iteration.
We can just wait for a couple of seconds to see if
Sure.
we have any more questions, and then we can go on to the next one.
I think there's a question on the comments section. I mean, chat, but I'm not sure if it's been addressed.
I think he answered.
Yeah, I just answered that. Thank you for the question,
right.
Alex. Honestly, very happy to just be here over at this event. We're slowly getting back into swing things as well over here. So as we work our way through our own small problems, we want to get involved with your competition, with the HW, and all the other competitions coming up soon.
Yeah, really happy to be a part of and then meet all the university teams from all across the world. So thank you for joining in, Mark. And
yeah, no problem.
Also convey the whole team that your presentation was really good.
Thank you. Thank you so much, and I hope you guys have a good rest of your event. I'll try to be there for the closing ceremony tomorrow.
Yeah, sure. Thank you. And I think next up at 3:30 we have CEO from Transport going to give a short presentation, and from CHC we have Nasrit, who's our finance and partnership lead. So he'll just give a presentation. He'll just introduce about transport and then let us know what's going to happen from 3:30. So if you're interested, you can stay or you can watch the recording later.
Awesome. Thank you.
Thanks.